Hello, this is Paul from Foresight Tech. In this lecture, we are going to go over transformation. Okay, we can make new functions from other functions. We learned a few type of transformation. So, if we have the original function y equals fx, we transfer from the original function, so we can do shift or reflect or stretch or compress, right? The basic four type. So let's one by one to review. What is shift? Okay, the original function, if we shift the left d unit, shift the left means what? Shift the left x goes to x plus d. Okay, don't confuse. Okay, go left is x plus d. Go right is x minus d. Shift up d is the total function, the value y goes up d plus d, goes down is minus d. Okay, the second type is a reflect. Okay, reflect about the x-axis. You remember? Okay, so you can imagine the function, the graph of the function reflect, flip about the x-axis. So all the value of the y goes to negative, right? So y equals negative times. Flip or reflect about the y-axis, can match it about the graph. Okay, is what? When we change x to negative x, okay, the y value no change, right? Flip or reflect about the y-axis is change x to negative x. Another type is stretch. So if we stretch vertically by the factor of a, usually the a is greater, should be greater than 1, right? Otherwise, we not call it stretch. Stretch by a factor a is times a. For example, stretch by 2, which means all the y value goes to double, right? Is 2 times the original y is the new y. That's vertical. The horizontal is different. Okay, if we stretch horizontally, this time be sure is x divided by a. If we stretch vertically by a factor of 2 is x divided by 2. Okay, it's no longer times 2 for x. This is a special one you have to pay attention. The last type is compress. Okay, either vertically compress or horizontally compress. Okay, if it's vertical compress a factor of b, of course, is less than 1, right? Like a 0.5 or 0.1 or 0.2. The smaller the compressor, the more compressed. Okay, if vertically is times b, right? For example, if b is 0.5, is just compressed by, okay, so half of the original height. The height goes to the original half. Okay, original times b. Okay, if it's a horizontally, is x divided by b. When x is divided by a number which is less than 1, so you're going to increase the number of x. Okay, this is the compress. And we see, for example, if compress horizontally compressed by 0.5, horizontally compressed by 0.5 divided by 0.5 is 2 times x. Okay, keep in mind that is 2 times x. Let me go on to show you example. We can make new functions from older. If the original function is the, so here the blue one f. Okay, can you see? Original is here. So we call the y equals fx. It's a given. So now we have a different type. Okay, different graph is the new functions transformed from the older function f. So a, b, c, d, e. So you need to match to 1, 2, 3, 4, 5. How to match? One by one. So can we look at the first function? Y equals f x minus 1. All you need to do is look back at the definition. X goes to minus 1 is shift left or shift right? Right. Okay. So don't make mistake. So I wrote here. For a is what? This function from the original is shift right 4 from the original, right? I simplify, I just write here. is from the original shift right 4. Okay, and you can imagine shift right 4 is get a which one? Shift right 4 you get a 3, right? So what do we get? We should get a 3. Okay, the graph for this function should be 3, the third graph. Look at the b. B is the original function plus 3. It goes up 3. Okay, you can imagine this goes up 3 is 1, right? Okay, or we write here. And this function is shift up 3 from the original. So 3 units. So we get the answer should be 1. Okay. Continue. How about the C? How about the C? All we need to do is find the relationship. And this C and this original C is times a factor which is less than 1. Times a factor less than 1 is compressed vertically, right? Vertically. Or if you look back, is this. Times here, right? Times b less than 1 is compressed vertically. Okay. Or you need to compare to the results. So is vertically compressed by the factor is 1/3, right? So what do we get? Compress f by 1/3 goes to number 4. Okay, so this goes to number 4. One more. How about the D? So this time we need to go 2 steps. Okay, the first step usually we go shift first, right? Shift the left or right first. This is shift the what? You shift the plus is shift the left. Okay, shift the left 4. Let me show you from the original shift the left 4. Shift the left 4. Then what? Times negative to the whole value of y. The y goes to negative, which means go to the bottom. From the top go to the bottom. Reflect about the x, right? So then reflect about the x-axis. So you can imagine which graph we can get. Okay, from the original shift the left 4, shift the left 4, and then flip about the x. So it goes to which one? Shift the left, flip about the x, so we get number 5. Okay, so here should be number 5, the graph. The last one is E. How to see? It's similar, right? Very similar. So first shift plus is shift the left. Okay, and then times 2. Times 2 greater than 1 is what? Stretch. Times the whole y is what? Is vertically stretched by 2. Okay, so 2 steps. The first shift. So the left from the original, of course, she left 6. Then vertically times 2 is a stretch, right? Okay, is a stretch, of course, by 2. You can see shift the left 6. The original here shift the left 6 because really here, and then stretch gets much higher than before. So we look at it. The only way is 2, right? So you get 2 is the graph of the function. Okay, so this is the first. And can we look at one more question? So here, if we have the original function with the graph here, so it's a semicircle, right? If we have a semicircle from here, how do you transfer to this function with the graph here? Okay, look at it. It's not a semicircle already. You have to do modification. How to modify? So think about how many steps do we need. You cannot get it to the end by 1 steps. Okay, we need 2 steps at least. Okay, so you can imagine how to do this. The first shift right? The second is higher to 3, 1.5 to 3, double. The higher double is vertically stretched by 2, which means what? Shift the right and then vertically stretched by 2 steps. Okay, if I write here is this. You can imagine I put here the original function. I put it here, and is a y. I use a y. Okay, so it's original. There is a what is a square root of 3x minus x squared. This is the original. Okay, we need to go to the final. If I put the final here, we need the final function. Well, I don't know what the final functions, but we just see. Okay, we should go through 2 steps from the beginning to the end. The first step is shift right. Shift right how many? From 0 to 2. Shift right 2. Okay, so I simply say it's 2 steps. If I put it here is this. Okay, and see the first step. Okay, shift is shift right 2. Right, shift right 2. We get a function, so I will put it here. And then after we get the function, the second step is what? Vertically stretched by 2. Vertically stretch. Sorry. By 2. Why is it by 2? Because from 1.5 go to 3. Okay. And now we can figure out the middle functions, and then we can get the final function. What the middle functions? Of course, the function should be goes like this. Y equals, I put it here. Shift the right. Do you remember shift the right? We change x to x plus 2 or minus 2. Shift the right is plus 2. Okay. Shift the right is minus 2. This is shift the right. So all we need to do is put it here like this. 3 original x goes x plus right, sorry, is minus 2. Okay, minus x minus 2 square, right? Okay, so did the function. Of course we can simplify. After we simplify, what do we get? Let me write here how to simplify. So this is distributed. We have 3. No, we have 3x minus 6, and this is the perfect square. Okay, so minus x squared minus 4x plus 4, and then x squared is negative x squared, right? For x, 3x minus negative is plus 3 plus 4, we get 7. Get 7x. Negative 6 minus 4 is a negative 10. Okay, so we get. See, this is the one we need. I copy here. Negative x squared plus 7x minus 10. So this is the middle function. You know, under the square root is what? This is a polynomial function. Take a root, right? It's an algebraic function, you know. So the last step from these functions, vertically stretched by 2. Vertically stretched is the whole function, the whole y times 2, right? Therefore, the final function we get is this: y equals the original times 2. Okay, this original, okay, the middle step. And then I copy negative x squared plus 7x minus 10. Okay, so this is the final function we found for this graph. Okay, that's all. Thank you.